In this video, I am here to explain about rational numbers and their decimal expansions. Class 10th. Okay, rational numbers and decimal expansion. Say, if I ask you the number before 2 means what you will do? Minus 1, that you will write 1, right? If I ask you the next previous number, what you will do? You will do plus 1 and you will write 3. Yes? But if I ask the numbers between 1 and 2 or between 2 and 3 or between 0 and 1, what can you say directly? See, before I asked, if I asked you preceding number of 2 means 1, you will say in a slash way, right? But can you say the numbers between 0 and 1, 1 and 2, 2 and 3 like that numbers can you easily say? No, you can't say. But the numbers like this, the numbers between 0 and 1, 1 and 2, 2 and 3 and so on, we call this all as rational numbers. Okay? Rational numbers. Rational numbers are nothing but what, ma? The numbers which are written in the form of p by q. Numbers which are written in p by q form. Okay, which are written in p by q form. Rational numbers means numbers which can be written in p by q form, where q not equals to 0. Q must not be 0. If q is a 0, no value for this, right? So the numbers between specified 0, 1, 2, 3 and so on, the numbers between those specified numbers we can call as rational numbers, because we can write those numbers in the form of p by q, and particularly q must not be 0. Okay. So now let us see some decimal numbers. Okay, decimal numbers like, say for example, I took 0.0875. What are called decimal numbers? What are called decimal numbers, ma? Whenever you have written few numbers between a specific dot, like the left side you will write, right side you will write, mm, okay, this is the decimal number, right? Let us convert this into p by q form. Convert into p by q form. How you will convert? First write the non-zero numbers 875, right? Now count right side, means after the point how many digits are there, that you have to count. 1, 2, 3, 4. So 875 by 1 is common for everything. And how many digits are there after the point? 1, 2, 3, 4. Those many zeros you must put under that. Okay, like this you can convert a decimal number to p by q form, that is rational number form. Okay. One more example, if I take 12.36 or 412.36. After point, whatever the numbers are there, we should read that as separately, individually, 3, 6 like that. We should not call 36, 47 like that. Okay. Each digit must be separately called. Okay. So this is 412.36. Again, write the non-zero values first. 4,000, 41,236 by, after decimal point, how many digits are there? 2 digits. So 1 after 2 zeros. In this way, we will convert the decimal numbers to rational numbers. Okay. And let us bring this to some normal form. Okay, normal form means both the numerator and denominator must be in the prime factors, or they must have only common factor as 1. Okay, in that way we have to convert. Let us convert these rational numbers. Okay, write 875 by, first take this 10,000. How many? 10 power 4. And if you take here 1, 2, 3, 6 by 10 square. Okay. Next, the upper one you prime factors. How you will take here in the units place you are having 5. So exactly it will go by 5. Let us divide it 875 by 5. 5 ones 5, 37, 5 sevens 35, 5 fives 25. So 175. 175 by 5 means what you will get? 5 threes are 15, 5 threes are 15. So how many 5s here completed? 1 5, second 5. So 5 square into 33 by 10 power 4. And after this, if you observe this 10, we can write even this also in the powers of 5. And also you will get 2. So 5 square into 33 by 2 power 4 into 5 power 4. Okay? 1 minute. 15, 7. Okay, ma? Here 5 square into 33 by 2 power 4 into 5 power 4. I have written this 10 power 4. Break it into prime factors. Prime factorization I did for 10 power 4, that we got 2 power 4 into 5 power 4. We know that in the previous classes you know no 10 power 4 or a power n is given, a into b power n if you take, a into b power n if you take a power n into b power n. This is formula for expansion. Power if you expand this, you will get this a into b whole power n equal to a power n into b power n. Okay. So in that way, I have written 10 power 4 as 2 power 4 into 5 power 4, and let us write for this number also in terms of 2 and 5 denominator 36 by 2 power 2 into 5 power 2. What you observe here, ma, the generalized thing, what you observed here in the denominator, you are having 2 powers into 5 powers, right? 2 powers into 5 powers, both you will see, right? So, any rational number or any decimal number, any rational number any number in its rational form if it have 2 power n into 5 power m in its denominator, that rational number is terminating decimal number. Understood, ma? Any rational number, if it have 2 power n into 5 power m in its denominator, that rational number is terminating decimal number. Let us see one problem. Before only we have seen 12.5. Okay. Let us write it as 125 by 10, because after decimal point you have only one digit, so you will write 10, 10. So now write this, ma. Now write this 125 by 2 into 5. is this what you can write 2 power 1 into 5 power 1, right? This here we are able to writing in this way means that is terminating. What is meant by terminating? Stopping. It stops the division at a particular point. Let us do that once. 10, 125, 10, 12 if you take 10 ones 10, subtraction 2 and let down this 5 down and 10 twos 20. This remains 5 here. As it is remaining here, let us put a point in the coefficient part and put a 0 in the particular remainder. Next, what you can take 5 is 50. That is 0. Got it? Got that 0 as remainder at some particular coefficient point. Okay? So, we call this type of decimal numbers as terminating decimal numbers. Okay? Terminating decimal numbers. And coming to non-terminating and recurring. Recurring is nothing but repeating. Recurring is nothing but repeating. Let us take one example directly. First of all, non-terminating means what, ma? Terminating is stop. Termination means stop. Non-terminating means it won't stop anywhere. Okay, it won't stop anywhere. And recurring means repeating. It won't stop and the number repeats. This type of decimals also there. Okay. So for that, let me take very easy example. You already know those all. That is 10 by 3. Okay, 10 by 3. So 3 and 10. First directly you can write 3 3 is 9. Now you will get one reminder. So other numbers are not there to get down. So what you will do? Put a decimal point in the coefficient and write 1 0. Now again 3 3 is 9. Again 1 remains. Decimal here 0 again 3 3 is 9. Again 1 0 9. This repeats, no? Here it is repeating and you are not getting even a 0 reminder. This type of decimals are called as non-repeating, recurring. Recurring means here 3 is repeating so many times. Here you are not getting 0, here 3 is not cutting. So you call this type of decimal as non-terminating recurring decimal. Non-terminating recurring decimal. Say for example here for this 10 by 3, here we are not able to write in the form of 2 power n into 5 power m, no? If you are not able to write this number in the form of 2 power n into 5 power m. Okay? So, as the denominator can't be written in this way, those types of decimals we call as non-terminating recurring. Non-terminating recurring. And one more is there. One more decimal type is there. What is that? Non-terminating. Non-terminating. Non-recurring. Non-terminating, non-recurring means, say for example, I took some coefficient. It goes on in this way. 2.4389, 438. Sorry, no repetitions. 43891685432856327 In that way, it's going on like that. You are not getting remainder 0 and here not even you are getting the same digits after the decimal. This type of decimal numbers are called as non-terminating, non-recurring decimal numbers. In non-terminating, non-recurring decimals, you won't get at all 0. That means it won't terminate. You won't get the remainder 0. And the coefficient part going on like that. How many times we take, it will goes on like that, the coefficient. No stop will be there. Those types are called as non-terminating, non-recurring decimals.